Hi, welcome to topic 6, where we'll be looking at how dietary lipids, commonly called oils and fats, can affect our health. So the areas we're focusing on is firstly what we mean by dietary lipids. We'll look at the various functions that lipids have in our body. We'll see how these things are classified as either saturated fats, unsaturated fats, essential fats. We'll look at the recommended fat intake, have a look at the role fats play in development of chronic disease. In particular, we'll look at the blood lipids, LDL and HDL. So as we've said before, the lipids are one of the macronutrients. So in this case, it's made up of triglycerides with long chains of fatty acids. So these are some of the long chains, lots of carbon atoms. So there's lots of stored energy here. So we've got 37 kilojoules per gram of stored energy. So a property of the lipids is they can't be dissolved in water. We've got two main types of lipids. We've got the fats. So an example would be butter, which stays as a solid at room temperature. And we've got the oils. An example would be vegetable oil, which will actually stay as a liquid at room temperature. So in the food that we eat, most of the fat is coming in the form of what we call a triglyceride. These triglycerides are made up of a backbone of glycerol, and off that comes off the three fatty acids. So here's an example of a triglyceride. Here's a glycerol backbone, and attached to that we've got our three chains of fatty acids. So these are long polymers. Now within these triglycerides, we've got these fatty acids, and they all differ. So some have got very long chains, some have got shorter chains, some are completely saturated. So you see carbons here completely saturated. Some are unsaturated. So over here we've got some carbons that are unsaturated, and some have got different shapes. So some are a straight line, and some here we've got a bends or kinks. And all of these will actually affect how the various fats will actually function. Okay, one of the most important functions for lipids and fats in our body is to provide us with energy, either from the food that we've eaten or from the fat that we actually got in our storage. So here we can see in this example how we're drawing energy from the fat that we have in storage. Listed here are some other functions for lipids. So we need the fat to carry the fat-soluble vitamins A, D, E, and K. The fat makes up the phospholipids in the membrane. We need fat as part of the nervous transmission system. We can see the fat layer actually helps protect our internal organs and also provides us with some insulation. And some of the fats, like the cholesterol, is actually involved in producing things like vitamin D and some of the sex hormones. Fat also provides flavour to our food. So this is a wahoo steak, lots of marbling, so lots of fat in there. That's going to have a much better flavour than a steak. This is very lean. The fat also helps us to make us feel full, as it's energy dense. Now, depending on the structure of the fat, we can actually classify it as either monoglyceride, diglyceride, triglyceride. The carbons can be saturated or unsaturated, so we can classify them as either saturated or unsaturated. So unsaturated could be either monounsaturated or polyunsaturated. And sometimes we can artificially change the fat and turn it into what's called a trans fat. So we've already mentioned the triglycerides. That's got the glycerol backbone with the three fatty acids, but we've also got monoglycerides, which has only got the one chain of fatty acids, and we've also got the diglycerides with two chains of fatty acids. So here in the diagram, we can see a monoglyceride. So we've got a glycerol backbone with one fatty acid chain. We've got a diglyceride with two chains of fatty acids, and now we've got a triglyceride with three fatty acid chains. Okay, we call the fat saturated if the carbons are surrounded by hydrogens and they have no double bonds. We've also got unsaturated fats, and they can either be monounsaturated or polyunsaturated. In the monounsaturated, we've got one double bond, and the polyunsaturated, we've got more than one double bond. So here we can see a saturated carbon, saturated with the hydrogens, and here's an unsaturated carbon. So the unsaturated fat has got a double carbon bond. All right, the saturated fats are straight-lined molecules, and so they compact quite tightly together, and they'll remain as a solid at room temperature. So the animal fats, dairy products like butter, coconut oil are all examples of saturated fat. Unsaturated fats, because they've got carbon double bonds, they've got kinks in the molecule, which means they don't stack well together, and so they'll stay as a liquid at room temperature. So most examples will be the plant oils, which tend to be unsaturated. So here we can see a saturated fat, saturated carbons. It's a straight molecule. Molecules will stack up closely together, and that'll form a solid at room temperature. So things like the butter and then the lard. Here we've got some unsaturated fats. So monounsaturated with the one double bond, polyunsaturated with two or more double bonds. So in both of these, they've got kinks in the molecule, so they don't line up together well. So at room temperature, these products will stay as a liquid. So again, saturated fat, carbons are fully saturated, no double bond. This is an unsaturated fat. In fact, it's a monounsaturated fat because it's got one double bond. Okay, in some processed foods like margarines, peanut butter, some baked products, manufacturers use a process called hydrogenation. So the purpose of this process is to convert a vegetable oil into a semi-solid product. So the food manufacturers want to change the texture of the food and also improve the shelf life of the food. However, the problem is during this process of hydrogenation, they also produce what's called a trans fat. So in this example with margarine, we're seeing the process of hydrogenation. You start off with the vegetable oil. So obviously it's a liquid at that stage. They pump in the hydrogen, and the hydrogen actually then converts the fat from what they call a cis fat into a trans fat. So now it becomes a semi-solid. So in the end, you've got a solid margarine. So the advantage is the product is now solid. It's less prone to oxidation, so it'll have a longer shelf life. But as was mentioned before, we've now got a problem that we've produced what's called a trans fat. So here we can see what's happened. We started off with a unsaturated fat with a double bond. So that had a nice kink in the molecule, which kept it as a liquid. After the hydrogenation, the hydrogens have switched sides and now become a trans fat. And now this will actually functions as a saturated fat. So we haven't got a kink in the molecule, it's now a straight molecule. So now it'll actually form a solid product at room temperature. So another type of fat is essential fatty acid. These are the fats that we must obtain from the diet. We can't produce these ourselves. So we've got the omega-3 and omega-6 fatty acids. So omega-3 you can see is coming off things like oily fish, and the omega-6 we're obtaining mainly through things like vegetable oil. So in this table here, we can see we're getting our omega-6 from various types of vegetable oil, whether it's corn oil, soybean oil, cottonseed oil, and with the omega-3, getting from foods such as walnuts, and also things like the oily fish, so things like salmon, sardines. Just so you know where they get the names omega-6 and omega-3. So the first one here is the omega-6. So you can see it's the sixth carbon with the first double bond. So it's omega-6. And this one's the omega-3. So you count them up, 1, 2, 3. So it's the third carbon that's got the double bond. So they call this one omega-3. Okay, so we're getting our dietary fats either from animal or plants. So if we're getting from an animal source, if you're getting from things like red meat or dairy products, potential problem because you're getting some saturated fat and cholesterol at the same time. If the animal product is fish, the good thing there is not so much saturated fat, and you're getting the good fats, the omega-3 fatty acids. So when we're getting our fats from plants, we're getting a lot of the good fats, the mono and polyunsaturated fatty acids, also the essential fats, omega-3 and omega-6 from products like the vegetable oils, nuts, avocados. But also from plants, if it's been modified by the manufacturers through hydrogenation, things like the margarines or some of the peanut butters, if they've been hydrogenated, you could also be getting in some trans fats. And we don't want those trans fats because they act pretty much like saturated fats. So in this diagram here, we can see animal products, things like red meats and also dairy products, a significant amount of saturated fat. And from plant products, such a lot of these vegetable oils down the bottom here, we're getting a lot of unsaturated fats, either monounsaturated or polyunsaturated. Okay, so in terms of fat consumption, our acceptable macronutrient distribution range should be in the range of 20 to 35%. No more than 10% should be coming from those saturated fats. Some also say we should be limiting our polyunsaturated fats up to 10%. You really don't want to be consuming any trans fat, or at least keep it less than 1%. And you want to also reduce your total cholesterol consumption. Our bodies produce their own cholesterol from making things like vitamin D and the sex hormones, so you don't need to take in any cholesterol, but if you do, no more than maximum 300 micrograms. So what happens if I don't get enough fat in my diet, or if I get too much fat in the diet? If I don't get enough, it might affect various body functions such as the membranes or storage of energy. If I get too much, it'll actually be stored as excess fat, and it'll lead to obesity. If I get too much of certain types of lipids, particularly the saturated fats and the trans fatty acids, it could lead to disease problems such as cardiovascular disease and potentially some types of cancer. So in this example here, we're seeing what happens if we consume too much fat in total. So too much fat, too many calories leads to obesity, and then obesity is related to things like stroke, cardiovascular disease, kidney failure. We need to talk soon about LDL and HDLs, but before we do that, we need to look at how those fats are actually transported through our blood system. So the way that happens is once we digest the food and then absorb the food in the small intestines, what we need are these cyclomicrons, which are made up of lipids and proteins, and they act to actually move the triglycerides across the small intestine into the lymphatic system and then eventually into the bloodstream. So here we can see a cyclomicron. So what's happening is the fat molecules that are being absorbed are being moved through the small intestine via these cyclomicrons, and then they move through the lymphatic system and eventually through into your bloodstream. All right. So besides the cyclomicrons, which are involved in mainly just moving the triglycerides, we've got other lipoproteins that are involved in moving other components. So in particular, what we need to look at is these low density lipoproteins, LDLs, and their job is to deliver cholesterols to the cells. And then we've got the high density lipoproteins or HDLs, and their job is actually to clean up your blood and actually remove the excess cholesterol and return it back to the liver. So you may have heard the term the LDL being the good cholesterol, LDL being the bad cholesterol, and the HDL being the good cholesterol. So it's bad because it deposits cholesterol. HDL is good because it actually removes cholesterol. All right, so you can see the cyclomicrons moving in the triglycerides in the first place, and then down here we've got the LDLs. So as we've said, their job is to deposit cholesterol, ideally to move the cholesterols to the cells that need the cholesterol, and the HDL, its job is to actually clean up the cholesterol from the cells and also from the blood and return it back to the liver. So here we can see LDLs and HDLs. So you can see the LDL, remember its job is to deposit cholesterol to the cells. So it's actually got quite a large amount of cholesterol within those lipoproteins. So having too much LDLs could potentially be a problem because you're carrying a lot of cholesterol. HDL, its job is to do the cleanup, so it's not carrying as much cholesterol. Now, consuming the wrong types of fat in our diet, particularly if you're consuming a lot of saturated fat or a lot of trans fat, can actually lead to chronic disease, in particular cardiovascular disease. There's also a bit of a link between consuming too much fat and which leads to obesity, and then that obesity can lead to problems such as breast cancer and prostate cancer. So when they're talking about cardiovascular disease, they're talking about a range of different problems, whether it's coronary heart disease, artery disease, stroke, hypertension, vascular disease. Now, the problem with consuming too much saturated fat, trans fat, and cholesterol is it can lead to osteosclerosis, in which the cholesterol is started to deposit inside the blood vessels, leading to hardening of the arteries and eventually leading to cardiovascular disease. So here we can see a healthy artery. So if we're not consuming excessive amounts of saturated fat, trans fat, get a nice clean artery there. If we're consuming a lot of saturated fat, trans fats, cholesterol, what will happen is you're getting a buildup of the LDLs, and the LDLs will start to deposit the excess cholesterol inside the artery walls, leading to hardening and restricting of the arteries, leading to blood clots, stroke, and cardiovascular disease. So here's a list of risk factors that we have control over in terms of cardiovascular disease. So of these, in terms of dietary lipids, dietary fats, the one that we're concerned about is abnormal blood lipids. So here we're going to focus on the levels of LDL and HDL. Okay, so we can see here if my diet consisted of lots of saturated fats, so if I ate a lot of red meats, if I ate a lot of say high fat dairy products, so high fat cheeses, what that saturated fat will do will be to increase my levels of LDL in my blood, which will mean I'll be carrying a lot of cholesterol. If my diet consisted of lots of trans fats, so if I ate a lot of hydrogenated margarine and hydrogenated peanut butter and various processed baked goods, what that might do is increase my LDL and at the same time lower my HDL. So these trans fats are actually a lot worse than the saturated fats because it's also lowering our HDL, it's lowering our good cholesterol. On the other hand, here, if I'm consuming the beneficial fats, so if I'm eating oily fish with omega-3, walnuts with omega-3, and at the same time getting a bit of exercise, what that's going to do is help to reduce inflammation and also increase my HDLs, so increasing my good cholesterol. So here are some general recommendations in terms of preventing chronic disease and preventing cardiovascular disease. So it's saying in total, I want to reduce my cholesterol levels to less than 300 micrograms per day. So aim is to aim for less than 200, but it's not total cholesterol we're focusing on. What we need to look at is the ratio between the bad cholesterol, LDLs, and the good cholesterol, the HDLs. So LDLs, that's the bad one, so we want less than 100 micrograms per litre of that one, and HDLs we want more as much as possible, so more than 60 micrograms per litre on the HDLs. So again, we're looking at a ratio of a high level of HDL versus the LDL. And in total, you also want to reduce your total triglycerides in the blood system as well to less than 150 micrograms per litre. So I can try to get to those targets of less than 200 micrograms of cholesterol and lowering my LDLs and increasing my HDLs by doing things such as reducing my intake of the bad fats, the saturated fats, the trans fats, and foods with cholesterol. I can also increase my intake of things like soluble fiber. Remember, things like oats will actually absorb excess cholesterol. I can also increase my intake of things which contain omega-3, like fish and walnuts. So the omega-3 will increase my HDLs. I want to decrease my alcohol intake, get a bit of exercise that helps to clean up your blood vessels and also lose a bit of weight in total. So here's some simple examples of reducing saturated fat. So I can trim off this excess fat on this piece of meat. I can reduce my intake of dairy products with saturated fat by not having the butter, not having the sour cream. I can reduce my intake of full fat dairy products and move over to the low fat versions. And lastly, here is a chart indicating your risk for cardiovascular disease, based on your intake of saturated fat, your levels of LDLs, your blood pressure, your age. Thanks, everyone.